Hello guys, this is Aman Shastri back with the third video on our most excellent Arduino tutorial series. Today we are going to be going into a bit of theory. The first two videos we looked at controlling an LED through the Arduino and even using a push button potentiometer. Today we are going to go into a bit of theory and explore Ohm's law. So let me quickly show you what Ohm's law is all about. Let's get you a good circuit view. There we go. So Ohm's law states that V equals IR. Let me tell you what this is quickly. V is the potential, if you can read that, difference across a resistor. You know what? Let me just draw a resistor really quickly. Imagine connecting this to a battery of voltage V. Yeah, current is going to flow through it, and this is the resistance with resistor R. Okay, now I is of course the current, right, through the resistor, and R is the resistance of the resistor. Now, how are we going to use this in our Arduino? Well, we are going to use this to measure the resistances of various resistors and more importantly, the potential difference through them. So here's how things are going to work. Let me quickly skip out of that. All right, now imagine taking a graph. On the y-axis, we plot the potential difference V. On the x-axis, we are going to plot the current. Now, if you measure the potential difference and current, for different values of potential difference V and current I for the same resistance, that's very important. You're going to get a straight line. And what's even more interesting is that it passes through the origin 0, 0. Now, the slope of this resistance, that is how much it is inclined. Imagine, let's take a point over here, V1 and I1. Compare that with the origin. The slope M is going to be exactly the rise over the run, right? The change in potential difference V over the change in current I. Okay, and that would be V. Let's just call this V1 comma I1. Uh, my apologies. That would be the other way around, right? You always get x coordinate first. So that would be I1 comma V1. Alright, anyways, moving on. The slope M would be the rise over the run. That would be V1 minus 0 over I1 minus 0. That would just mean that the resistance is the voltage over the current. If you see, that is just a rearrangement of our Ohm's law. Alright, now if we want to integrate this to our Arduino, what we're going to do is this. Let me quickly clear up the whole screen for you guys. There we go. Okay, now imagine dragging a 5 volt from the Arduino. I mean, yeah, I've drawn a battery, but let's just imagine that's the 5 volt. Shall we? Alright, sweet. Now, say we want to measure the potential difference across an unknown resistor. Let me draw our unknown resistor right here first. Let me call that R. Yeah, and we have another known resistor. Let's say R1. Now, R1 is our known resistor. We know the value of R1, and then we have R, which is our unknown resistor, right? Now, what's going to happen? Current is going to flow through the 5 volt from the 5 volts positive line into the resistor, the first resistor. Right now, because these resistors are in series, that's very important. They are in series. What's going to happen is current through R1 is going to be equal to current through R2, and then that's just going to complete the circuit. And what we're going to do something is really clever. We're going to create something called a voltage divider right between these resistors. We're going to drag another wire to analog pin is 0 on our Arduino. This is going to measure, it's going to measure the potential difference across this resistor R, or unknown resistor. That is what's going to happen. So that is essentially what's going to happen. So let's get right into making this circuit. Here we go. Just get that out of the way. There we go. And yeah. All right, so let's get right into making the circuit. So first of all, what we're going to do is we are obviously going to set up our power rails. So let's drag a line from 5 volts to one of the power rails and the ground to the ground. It's always a good habit to always start with your power rails, connecting your Arduino to the breadboard. Otherwise, sometimes what's happening is you do all the other connections and then you realize I haven't given any power to the circuit. So always give power to your circuit. Now, I'm going to take a 1k ohm resistor, 1000 ohm. That's the unit we measure resistance in ohms. And I'm just going to connect it anywhere from the breadboard as long as the two terminals are not directly connected, like so, right? That's cool. And I'm also obviously going to provide power to the circuit. How am I going to do that? I'm going to drag a 5-volt line to the one of the terminals of the 1k ohm resistor. All right, now let's take another resistor. This is going to be our unknown resistor. um for purposes of ease, I'm just going to take a 5 ohm resistor. We know what the value is, but we're going to work backwards. Let's imagine we don't know this is a 5k ohm resistor. Anyways, let me connect that, and there we go. And lastly, we're going to ground our circuit. So we're going to take a wire from the other end of the 5 ohm resistor and connect that to ground. Now, like I said, in between these resistors, we are going to put a wire. We're going to connect a wire and drag that straight to analog pin A0. A0. Now, let me explain the mathematics of all this business. So, give me a second, if you will. Okay. Now, how this whole business works is like so. Just give me a second. Yeah, there we go. Now, like I said, the potential difference is directly proportional to the current across the resistor Vi. And we of course know that in a series combination of resistors, that is, they're connected one after the other, like so. Forget the bad drawing. Let's say these resistors have resistances R1 and R2. Now we have our potential difference V set up, we have a current set up, right? The equivalent resistance, right? So imagine replacing these two resistors R1 and R2 with a single equivalent resistor of, I like to call it R sub equivalent, is just going to be equal to R1 plus R2. Applying Ohm's law, we get the total voltage equals I times R1 plus R2. But on rearrangement, we get V over I equals R1 plus R2. Now look at, we already know R1, we already know V, the voltage that is provided by the digital pins, or by the power rail in this case in the Arduino is 5 volts. We can find out I in a clever way, and we need to find out R2. On rearrangement, we get R2 equals V over I minus R1. Now what we're going to do to get I is something really clever. So let me just let me just get back our original resistors, R1 and R2 right over here, R1 and R2. Now we know that the current through R1 has to equal current through R2, right? Now what's going to happen is the potential difference through the first resistor, I'm going to call that V1, equals the current. It's the same current that's flowing throughout the whole circuit times R1. Let me get a better view of that. Current times R1 from, again, Ohm's law application, right? Now we, from that we get the current is just equal to V1 over R1. Now we have a way of measuring V1 from the Arduino. You remember we connected the pin from the middle of the resistors to A0. Well, what that's going to do is that's going to give us the potential difference from R2. That's going to give us a potential difference across R2. So imagine hooking up a voltmeter over here, right? And that's going to give us a potential difference across R2. When we connect the pin to A0. Obviously, now since these two R1 and R2 are in series, the 5 volts, that is the total voltage, has to be the sum of the potential difference across the individual resistances. So that is 5 volts equals V1 plus V2. We found out V2, we know how to find V2. On rearrangement, we get V1 equals 5 minus V2. Upon plugging this equation back over here, we get the total current equals 5 minus V1, right? That is the potential difference, excuse me, 5 minus V2. That's the potential difference across the first resistor, R1, over, well, R1. That's it. Now this is the last bit of our theory. Let me just try that again. R1. Now something we're going to do is really clever, right? We can use this value of the current we get to find out the second resistance. Now we already know V2, we're going to find that out. V2 equals I times R2. So R2 is simply V2 over I. And this is it, guys. This is it. We know how to find our current. We know how to find the potential difference. This is the golden formula right here, which we are going to use. All right, having said all of that piece of business, let us go into coding this thing. All right, on to real talk, guys. On to real talk. Let's get you a good code view. All right, let's arrange that a bit better. All right, so as always, we start by declaring our variables up top. The only pin we're connected our Arduino to is A0. So I'm gonna call it R pin, resistor pin, equals A0, and that's the only variable. No, we need another variable to store the value we get. Exactly. So int val equals, let's initialize it to 0. We need a lot more variables, in fact, right? Let's declare a variable for the voltage which we will convert the reading to. So the idea is we convert the voltage, we convert the analog reading we get. Remember, it ranges from 0 to 1024 to a range between 0 to 5. That just gives us the voltage through the second resistor, right? Int v, let's again initialize that to 0. We need a variable for the current, also going to be equal to 0. Now let's just stop for a moment and think. Are these all going to be integers? Integers are always going to be 0, 1, 2. They do not have decimal places. If we need to be accurate, we need decimal places. Otherwise, the whole thing is going to get rounded down. And in fact, the current provided by the Arduino 5 volts is so small, it's 0.02 amperes. The current is going to remain read as 0 itself if we do not make it a float. That's a decimal point. So right now, let's convert all of these to floating points. Actually, we do not need to convert int the value which we'll read, but we can convert everything else to floating points. Float v, float I. What else do we need? We have our known resistor. Also, it's better to have all of these things as floats, decimal points. Float. Okay, what was the known resistor value we used? It was 1k ohm. Always standard units, 1000 ohm. We do not declare our variable name. Let's call that the first resistor, shall we? And of course, we have the second resistor, float R2. We do not know what that is. This is an unknown resistor. That would be 0 ohms. All right, so we got our potential difference across the second resistor. We got the total current in the circuit. We got the first our known resistance R1. We got our unknown resistance R2. All right, so that should ideally finish all our declaration of variables. Now let's move on to our void setup. In the void setup, we need to do only one thing. We need to be able to see the values, correct? So let us initialize the serial monitor. The serial monitor is basically where we can connect, we can communicate to our computer using the serial, right? So we're going to say serial dot begin That's the command to initialize the serial monitor, and we give it the old trusty 9600 baud rate. That just shows the rate at which we need to, we'll be communicating. The Arduino will be communicating. 9600 is the most frequently used baud rate. Now, let's move on to the while loop. All we're going to do is do an analog read. We're going to read the value which is, provided by these resistors, combination of resistors. So val equals, we're going to very simply do an analog read of which pin have we connected it to, or pin. That's it, right? And then we convert that, it's a fraction of 1024 or 1023 if you will, to a fraction of 5. So what we need to do is we are going to say v equals val times 5 over 1023. So imagine we get a full high value of 1023, which is actually not possible, but let's just imagine that, right? What's going to happen is 1023 over 1023 is going to be 1, and then 1 times 5. So essentially we are converting it from a fraction of with respect to 1023 to a fraction of respect to 5. And because the Arduino provides 5 volts DC, we are going to get a value between 0 and 5 always. Right? Don't forget your decimal points. That signifies that we are dealing with floating values over here. All right, so we get the potential difference across the second resistor. So let me write that as a comment. V across R2. Right. Now we need the potential difference across the first resistor to calculate the current. Let's just go ahead and calculate a current for that. We are going to say I equals, I stands for the current, 5 minus V. Because 5 minus V, as I said in the working, is going to be the potential difference across the first resistor. 5 minus V over R1. That's right. This is essentially, the potential difference through R1 divided by the resistance of R1. That is going to give the current through the whole, circuit, right? Lastly, or there are a couple of more things to do rather. What we are going to do is, let's see, we have a current, we have a potential difference set, we have our first resistor set. Now, how do we calculate this resistance of the second resistor out of all of this? R2, that is our unknown resistor, equals, actually, before all of that, let's just print out the value of V just to see what we get. Print V, right? Let's do that. Rather, I should do serial dot print ln. That's going to print all the values on each new line. Serial dot print ln V. So that's just going to provide the potential difference across this resistor. Now, ideally, if we do the math, we should find out that the potential difference across the 5,000 ohm resistor has to be relatively a lot compared to the 1 ohm resistor. So it has to be at least, something like 3 volts minimum. So let's go ahead and test that out. Okay, let's upload it. Hope that's happy. All right, let's see. I'm gonna do my best to capture. Right, there we go. We get a nice 4.18 volts, and that is the desired range of potential difference. Right, as you can see, we're getting a nice 4.18 volts across the 5 ohm resistor. No, this is not through the 1000 ohm resistor, only through the 5k ohm resistor. Sorry, I said 5 ohm at that time. All right, so that signifies we are on the right path. Let's continue. All right, what we're going to do is, like I said, let's bring back that current statement. I equals, what did we say? I equals 5 minus V. That takes the potential difference across the 1k ohm resistor divided by R1. Perfect. Now all we need to do is apply this into our Ohm's law for the second resistor. You remember that equation, R2 equals V over I. That is it, guys. That is it. Hopefully this should take care of the whole business. Okay, now let's see what we did. We're missing a step. Did you guys catch that? V over I. That's going to give the whole resistance, the total voltage, or is it? Okay, let's test this out. The total voltage across the 5k ohm resistor over the total current. All right, it should be V over I. Let's go ahead and serial print that. Serial dot print ln R2. Alright, let's see how accurate our Arduino gets. Okay, so let's go ahead. Yep, there we are. If you can see that, it is giving about 5100 ohms. Let me actually introduce a delay in here. Let me delay it by, I don't know, half a second, 500 milliseconds, to make it easier for you guys to see. There we go. Yep, we're getting pretty accurate. It's reading a very close to 5000 ohm. It's reading 5089 ohm. So it's incredibly accurate. What we're gonna do is, let me just quickly disconnect the Arduino and let's put another resistor to the test. Let's choose let's choose a 2k ohm resistor, 2000 ohm. So the thing is, the closer value you get, the closer the value the unknown resistor is to the known resistor, the more accurate things get. All right, let's test it out. Okay, we don't need to change anything in the sketch because we still have the same known resistor. And as we can see, it reads on the dot 2k ohm. So this is incredibly accurate, guys. This is really accurate. I mean, it keeps fluctuating, but the value is incredibly accurate. I would say there is like probably a 5% error, but that's really accurate. All right. Why don't we introduce, okay, let's introduce a larger change this time. I'm going to take only 100 ohm resistor. So, there's a whole magnitude of order apart. All right, let's try this thing. Okay, replace the 2k ohm resistor with the 100 ohm resistor. Let's test a 1k ohm resistor and our Arduino in every single way we can. All right, let's test this out. See how much we get. There we go. 100 ohm on the dot. 98. It's about 1.18 ohm apart, but that'll pass. So that is it, guys. Today was a bit of theory, and we really need to, learn a bit of theory, especially Ohm's law, because such things are really the basis of all of electronics. Yeah, with that said, thank you for watching this video, and I will see you next time. Bye.